Hello, my name is Patrat Kitbamrong, and this is my demonstration for Homework 3 for Graphical Application Development to create the evolutionary art with Dr. Fernandez's framework. You can see here, this is a very familiar window here with the transducer and, of course, the genetic algorithm itself. This is a painting of a Picasso painting here, really complex with bright colors. So this is a really nice thing to demonstrate here. So let me talk about the main feature here. So we were supposed to come up with our own genotype to phenotype mapping, and the one that I came up with, the one that we will look at now, is a bunch of triangle. So this is 14 a triangle made up of 14 doubles. In this particular population, we have 200 triangle per individual and 100 individual per population. And in this case here, you can see that for triangle here, we can do 10 triangle. And this is it's not really going through the genetic algorithm because there's only really 10 generation of it here, but this is basically what it looks like, the triangle here. And the 14 double also make up the brushes. The brushes is a linear gradient brush, so you can see that the color is changing as you look through the triangle, and also the transparencies here. And of course the transducer also take command line, of course, right? So you can do more generation, maybe of 20 individual or even 100 individual here, and let this run for a bit so we can talk about the main feature here. If you notice this bunch of button here, so this is after 100 generation, so you can see a bunch of command here that I've modified to the transducer itself. So the GAP command also still does the same thing, where with Dr. Fernandez's code, where it generates ellipses or a bunch of circles or that make up the genetic algorithm. But the way I modified it is that you can run other genotype to phenotype mapping using the same population. So you can go with a triangle here, which I also already explained, and the fitness function was also modified so that it would look at the brightness of the picture also. If the picture is very bright, it would error in such a way that it's undesirable to have anything drawn there. That's a different color. But we can go on to look at some cool stuff here. With this, in this program, you can also run other genotype to phenotype mapping here. So this is a bunch of square. So with the square here, this is a little sheety. The genetic algorithm is cheating a little bit by knowing what color the target picture would be. So if you notice here that it would kind of guess that there's black here, where there's black here, and there's a bunch of green here, so it kind of guesses of the green, but it's really me feeding it the information from this image here onto the genotype to phenotype mapping to create this color. So you can keep doing square, or you can go ahead and change back to your triangle, and it will reset, and you begin with a triangle again as you keep doing more triangle. And the last one here is the idea of creating this picture from itself, meaning small little picture of itself here. So you can try that. So it stands for mosaic. So when you look at this, it's basically this picture, but in smaller pieces to try to create this picture. And of course, I'll show the result of this program running in long term. So it seems to me that when running this program, the complexity makes it really hard for the genetic algorithms to get anything to have anything that look even similar. So the idea here is that maybe if we just change the color a bit, and let's close this down, I'll have something that's more with more contrast. So in this case, I ran this thing for 50 generation, which is not really that high, but also we can try it with and you can see that the color here is almost very similar, the big band of dark here. And of course you can run it with other algorithm here, as I shown you earlier. You can change them to triangle. And to note, every time you change into a different scheme, a different mode here, if you say. What happened here is that you also reset your canvas, so you don't have to worry about the memory leakage or anything like that. But the fitness function, the function that go into the genetic algorithm stays the same, so you don't lose anything. So, and you can also do mosaic, of course, and you see that the picture is actually making up of the small little ones here, as you can see. And this is getting a lot better result when we do the squares, as you can see. And like I said, you don't really lose any of your other previous generations, so it should get better and better. But then this is still pretty complex, so we might want to look at something a little simpler. So we can look at some ponies, some little pony with bright color and a lot of solid colors. And of course we can try the triangle scheme, which, like I said, 10 population doesn't really do much of it, but you can try to play around with it a little bit here and keep it running overnight. I find that 10,000 generation would take about 3 to 4 hours to run. And of course the sheedy method here, you can see a lot of white. And of course the mosaic, which is sort of my favorite one, where you can see the little ponies everywhere here. But it doesn't really look anything like the original. But I haven't really run this one for that long a time. So now let's take a look at some result of this algorithm. Running it with the Mona Lisa. So let me keep the pony there. And with the Mona Lisa here, and with the triangle. And this is for about 2,000 generation with a triangle. You see that the black is starting to come in, I guess. And then the color, the brightness of the color here is a little brighter than the darker spot. So this is getting closer. And the mosaic one, even with 10,000 10,000 generation, doesn't really seem to go anywhere unless you sort of see Mona Lisa in there. And of course this picture, which is really complex, 5,000 generation doesn't really do much of anything there. And of course there's some more, and let me scroll through this a little bit more. And for this one, this is with triangle. This is actually 10,000 generation. And you can see that the dark spot here and the bright spot is starting to come in, I guess. And of course this is the interesting one, the sheedy algorithm one, where you can actually see bands here. And the ponies. And that's that. And that's pretty much the algorithm. And thank you for watching.